Good evening, class. We are looking at practice test for Module 5, Chapter 9, Sequences and Series. Of course, part of the final exam. Write the first 5 terms of the sequence. A7 equals 9 times 1/4 to the power of k minus 1. Simply put, replace the k with 1, 2, 3, all the way to 5. So when we put 1, 1 minus 1 makes it 0. And 1/4 to the power of 0 is 1. The answer is 9. Let's change the k to 2. This is 1. 1/4 to the power of 1 is 1/4 times 1 is 9/4. And we can continue with the rest of them. As long as we can show work for 2, we can figure out the rest of them. So the first one is 9, the second one is 9/4, and we continue. We get 9 over 16, 9 over 64, and 9 over 256 as the 5th term. For the sequence A7 equals 2, A7 minus 1 plus A7 minus 2, given A7 equals 6, A sub 2 equals 3, first find the following term. The first term is simply given as 6. The second one is simply given as 3. So using this, if you want the third one, okay, so first a simple definition. A difference equation, also known as recursive sequence, is an equation of the form a sub n plus 1 is f of a sub n, where a sub 1 is given and f is a real valued function. A solution is a sequence a sub 1, a sub 2 to a sub n, satisfying the given difference equation. That's the definition. So with that being the case, if I want a sub 3, I get 2a sub 2 plus a sub 1, because what does that mean? A sub n equals 2 a sub n minus 1 plus a sub n minus 2. It means if you want any term, pick the previous one multiplied by 2, and then the one before that, and add them up. So a sub 3, the one before that is a sub 2 multiplied by 2, and add up with a sub 1. Therefore, 2 times 3 plus 6, they add up to 12, because this is 6. Now, using this technique, now the next one is a sub 4. That means pick the previous one, a sub 3 times 2, so 2a sub 3 plus a sub 2. That's the meaning of it. So 2 times a sub 3, which is 12, plus a sub 2, which is 3. This is 24. Plus 3 is 27. And again, we can answer. The first one was given, the second one was given, and the third one is 12. The fourth one is 27. And I'm going to leave the last one for you to find it in the same manner using the difference equation that is given. Determine whether the sequence is arithmetic, geometric, or neither. If the sequence is geometric, find the common ratio. Well, let's look at some definitions. An arithmetic sequence, what is it? Arithmetic sequence can be defined recursively as a sub n plus 1 equals a sub n plus d. That means just add a constant d. It's called the difference or distance. Or explicitly, a sub n equals a sub 1 plus n minus 1 times d. Whereas in the case of a geometric sequence, recursively, A sub n plus 1 is R times A sub n. That means you want any term, pick the previous one, multiplied by common R known as ratio, or explicitly, A sub n is A sub 1 times R to the power of n minus 1. So in order to figure out whether it's arithmetic or geometric or neither, we want to see if the difference is a constant or the ratio is constant. In this case, we notice that the ratio of A sub 2, that means 0.25, to A sub 1, that means negative 1.125, is negative 2. And the ratio of these two, A sub 3 to A sub 2, is also negative 2. That makes it a geometric sequence, and therefore R is negative 2. For part B, if we look at the ratio of A sub 2 to A sub 1 and A sub 3 to A sub 2, they are not equal, because A sub 2 to A sub 1 equals 8 over 6. A sub 3 to A sub 2 is 11 over 8, and they are not equal. The cross product shows that they are not. If you look at their difference, this adds a 2, this adds 3, and therefore they are neither arithmetic sequence nor a geometric sequence. Again, this one, we probably notice immediately that there is a ratio here that works out here too. So A sub 2 is 1/2 over A sub 1, which is negative 2. I hope you realize it's a complex fraction, becomes negative 1 over 4. If we divide this to negative 1 over 8 over 1/2, in other words, A sub 3 to A sub 2, we get to the same answer, negative 1/4, which makes this also a geometric sequence, with R being negative 1/4. Write the arithmetic sequence for this case, 32, 24, 16, and so forth, in the standard form, meaning find A sub n. And I'm reminding you that here's the recursive format, A sub n plus 1 is A sub n plus d, and here's the explicit format, A sub n equals A sub 1 plus n minus 1d. And we want to find A sub n, which means we need to find the first term. Clearly, the first term is given as 32. And we need to find the distance. You notice there's a difference of 8, but it's getting smaller, so minus 8. Again, difference of 8 getting smaller, minus 8. So the distance is 24 minus 32 equals negative 8, or the difference. So using this formula, we get A sub n equals 32, which is A sub 1, plus n minus 1 times d, which is negative 8. And so this is minus 8n plus 8. These two combine into 40. Now, it's always a good idea to check. Now, how do you check? Very simple. If n is 1, do you get the first term? Minus 8 plus 1 is 40 equals 8. If n is 2, do you get the second one, 24, so on and so forth. So you check your work. Fill in the blank. 139 is which term of the arithmetic sequence 1, 4, 7, 10? Well, first and foremost, the arithmetic sequence, we know it has a general solution in the form of A sub n equals A sub 1 plus n minus 1 times d. This one has a sub 1 equals 1, and here's the difference. We are adding 3 again and again. So a sub 1 is 1, these 4 minus 1 is 3, and you want to check it. 7 minus 4, 10 minus 7, all of them are the same. Now we're going to put it into this equation, replace the a sub 1 with 1, plus n minus 1, replace the t with 3. And now if we distribute, this becomes 1 plus 3n minus 3. These two add up to negative 2. Now, this is the general term. So a sub n plus 1. Okay. A sub n is equal to 3n minus 2. We set this equal to the given number 139, and we find n. So this is a sub n equals 139, and the formula is 3n minus 2. And all you have to do, move the 2, negative 2, becomes positive 2 on the other side. You get 141. You divide by 3, and n becomes 47. Okay. So 139 is the 47th term. Okay. Answer the following question. Find a formula for the general term a sub n of the sequence, assuming the pattern of the first few terms continues. Again, reminding you, the geometric sequence is in this format. We've seen it many times by now. We want to see if it's a geometric sequence or not. All you have to divide 4 by 0.8, divide 20 by 4, divide 100 by 20, and do they all give you the same? Obviously, 100 divided by 20 is 5, 20 divided by 4 is 5, 4 divided by 0.8 is 40 divided by 8, it's also 5. And so the first term is 0.8. We want to find D or R. When we do the division, it works out, and therefore it's a geometric sequence. And again, I want to emphasize, we find either D or R. This one, the ratio tells us it's an R. So we're going to stick with this formula. A sub n equals a sub 1 r to the power of n minus 1. So a sub 1 is 0.8, and r is 5. So this is a general formula. A7 is 0.8, 5 to the power of n minus 1. If you don't, you have to keep the 5 in a parentheses because of the 0.8. Now we want a sub 8. Okay, so replace the n with 8. That's all you have to do. And so this is 7, 5 to the power of 7 times 0.8 using a calculator gives us 62,500. Question number 7, find the ninth term of the geometric sequence whose initial term a sub 1 is given as 4, and the common ratio is given as 2. So obviously we're going to use this formula with a sub 1 being r, a sub 1 being 4, r being 2, n being 9. That's what we want. Why is it n9? Because we want the ninth term. So a sub 9 is, we can write this first as 4 times to the power of n minus 1. And so replace the n with 9 and you get 8. 2 to the power of 8 times 4 is 2 to the power of 10, or 10^24. We want to evaluate this summation. The summation of k squared minus 1 from 3 to 7. Well, what this means is start from the lower limit, which is 3. So 3 squared minus 1, and end up with the upper limit, 7. So plus 4 squared minus 1, 5 squared minus 1, 6 squared minus 1, 7 squared minus 1, add them up. That's the meaning of this summation. Again, lower limit is 3, plug in. Then go all the way up to the last one. Whatever is in between all the integers, or you see and say, you know, whole numbers or positive integers, cover it. 4, 5, 6, 7. Okay. Now, of course, 9 minus 1, 16 minus 1, 25 minus 1, 36 minus 1, 49 minus 1. Okay. And just add them up, you end up with 130. So I'm going to assume everybody can add them up. The purpose of this question was to make sure we understand how we expand summation. Okay. How we expand summation. Write the arithmetic sum using sigma notation. This is known as sigma, summation, or sigma, which represents addition. So we have 9 plus 4 plus negative 1 all the way to negative 26. And this is an arithmetic. So we're going to remind everybody about the arithmetic sequence. Recursively, a sub n plus 1 is a sub n plus d. And we said explicitly is a sub n equals a sub 1 plus n minus 1 d. And so what we need to do when this question is given, we need to find the summation of a sub n as n goes from 1 to n. So we have to find a sub n, and we need to find n, yn, because it stops at some point. And that is the term we have to figure out. So we need to find the value of n, in fact, this last one. So going with the arithmetic sequence, we know the first term is 9, so a sub n is 9. The d is 4 minus 9, or negative 5. And by the way, we are going to double check, meaning 4 minus 9 is negative 5, minus 1 minus 4 is also negative 5. So you want to check that to make sure you haven't made a mistake. So in this case, we are going to put a sub 1 is 9, d is negative 5, which means now minus 5 and plus 5. And of course, 9 and 5, they add up to 14. So here's your a sub n, the formula for a sub n. And the value for a sub n is this one, because we don't know which term this is. We need to figure out the value for n. So we set this one equal to the last one that we have here to figure out what is n. Obviously, we're going to subtract 14 from both sides. get negative 40. Divide by negative, negative over negative gives us positive 8. So n is 8, which means in the summation, we use a sub n. We start with a sub 1, that means n equals 1. And we go up to n, this one is 8, and we are done. We want to evaluate the summation of 3 times 2 to the power of n minus 1 as we go from 1 to 14. Okay. And I hope you recognize it is a geometric sequence. And since we're adding them up, we call them geometric series. Again, reminding you of geometric sequence, arithmetic sequence, and the summation for a geometric sequence, S sub n is a sub 1 times 1 minus r to the power of n over 1 minus r. So I think it's clear the first term is 3. If you compare it to this one, to this formula, and r is 2. However, just to prove and we don't take a chance, let's write the terms and add them up. If n is 1, 1 minus 1, 0 to the power of 0 is 1, so we get 3. If n is 1, so plus, we get 3 times 2 or 6. If n is 3, 3 minus 1 is 2, 2 squared 4 times 3 is 12. So I hope you see that we have 3 plus 6 plus 12. Just plug in n equals 1, n equals 2, n equals 3. And of course, you have to go all the way to 14. That becomes a fairly large number. So clearly a sub 1 is 3 and r is 6/3 or 12 over 6, right? Which makes it 2. So we could have seen that in the first place. But if we didn't now, we can see that. And so we are going to use this formula in order to find the summation of 1 to 14. Instead of writing them up and adding them up, we're going to change the n to 14. You have everything else. A sub 1, 3, or 2. So n is 14. Replace this with 14. Replace this one with 14. Now using a calculator, raise 2 to the power of 14, subtract that from 1 times 3, divide by negative 1, and it becomes positive 49,149. Okay. That is known as partial sum in essence. I want you to know that. Partial because it stops at some number. Okay. It goes indefinitely. That's not a partial sum. So with that being the case, what happens in a case of arithmetic sequence? First of all, in this case, find the partial sum S sub 11 for the arithmetic sequence when A sub 1 is 9, D is 3. Well, again, this is the recursive format. This is explicitly, and now the sum S sub n is n over 2 A sub 1 plus A sub n. And that's fine. If you have the first one and the last one, it's easier to use that formula. However, if you don't, since A sub 1, let me just show you how we arrived. This is A sub 1, and it remains. But what is A sub n is A sub 1 plus n minus 1 times d, and that's how we get to this formula. And therefore, we are going to use that one where A sub 1 is given, d is given, and then n is 11. Okay, because they said S sub 11. So obviously this is 10 times 3, 30, 2 times 9, 18. Uh, 48 divided by 2 is 24. 24 times 11, 264. Find the infinite sum if it exists for this geometric series. Now, first and foremost, the first term is -2. Then you divide this one by this one to find the R. And then this one by this one to double check that. So 0.5 divided by -2, I hope you realize becomes -1/4 because 1/2 over -2 is -1/4. Now, when that happens, everybody, now this formula, when r is between -1 and 1, changes to this formula because r to the power of n goes to 0. As n gets larger and larger, r to the power of n gets smaller and smaller, and eventually becomes 0. And because this number is between these two, we are going to use this formula, which means S sub n, in this case, is a sub 1 minus 2 over 1 minus r, which is -1/4. So we're going to use this formula, and this is what we are going to get. You may recognize this is plus, so the bottom is 5/4. And so you can probably see this as -2 over 1, 5 over 4. So 2 times 4 is 8. 1 times 5 is 5. And we have a negative sign. So -8 over 5. That's one way to do it. The other one is to multiply the top and the bottom by 4. That's taking care of the complex fraction a slightly different way. All right. We want to find the infinite sum, again, if it exists for this, which means we should be dealing with a geometric sequence with the value for r being somewhere between -1 and 1. First of all, if you look at this, you should be able to tell in a matter of comparison to this one, this is a sub 1 and this is r. But just to be on the safe side, you can expand that. So if k is 0, if k is 1, this becomes 0, so this becomes 9. You probably remember this one when we did it actually in the very first case, okay? So if you choose 1, you get, this is 1/4 times 9 is 9/4. And if you pick 2, 2 minus 1 is, like I said, 1/4. If it's 3, 3 minus 1 makes this 1 over 16 times 9, 9 over 16. So this is what we get. And yes, it's a geometric sequence with the first one being 9 and r being 9/4 over 9, or simply, as I said, 1/4. It's clear what we have. Because r is between -1 and 1, we can use the formula here. So replace the a sub 1 with 9, 1 minus r with 1/4. And now this is 3/4, and you may recognize this one as 9 times 4/3. 9 divided by 3/4 is the same as 9 times 4/3, which gives us 3 times 4 is 12. I mean, it's just dealing with basic fractions, so that shouldn't be a big deal. Now let's look at an application. On each swing left to right or right to left, A pendulum travels 90% as far as on its previous swing. So if it goes from left to right, then when it comes back, it's not the same distance, it's 90% of that. If the first swing is 10 feet, determine the total distance traveled by the pendulum before coming to a complete stop. I hope you recognize this is geometric sequence. Why is that? We have the initial value, or a sub 1, as 10 feet, and then it gets multiplied by 90%, or is a 0.9. And because r is between these two numbers, we can use this formula. So again, recognize this is geometric sequence and why. Okay, you have the first one and then times a constant, in this case 0.9 times a ratio. So 10 divided by 1 minus 0.9, 1 minus 0.9 is 0.1, and I hope you know 10 divided by 0.1 is 10 times 10, or 100. As far as the units, this was 10 feet, so we use the same unit, everybody. We must use the same unit. Okay. A ladder consists of 31 rungs if the rungs taper uniformly from 18 to 28 inches. How much material would be needed for the 20th rung? So the idea is, here's the ladder, okay? Now this is not to scale, but we have 1, 2, 3, how many? We have 31 of those. The smallest size, you know, when it comes to ladder, the size changes. So if the top one is the smallest one, as 18, the bottom one is the largest one, as 28. So because they change uniformly, meaning this one we add a little bit to it, some constant gives us the second one. We add the same constant, gives us the third one, the fourth one, and all the way to the last one, 31st one. So n is 31. A sub 1 is 18. Last one, A sub 31 is 28. What do we want? A sub 20. So this is understanding the problem. It's AS, short for an arithmetic sequence with the given information. Okay. Therefore, we're going to use A sub n is A sub 1 plus n minus 1 times d. And since we want A sub 20, first of all, A sub 1 is 18 and d is 31. We are going to replace the n with 31. Okay. 18 plus 30d. Okay. Why are we doing that? We want to find so we have everything, but is missing is the d. If we want to find this one in general, we need to find the d. So what did we do? We use the last one, which is A sub 31, and we use the first one, which is 18, and therefore we can find the missing d. This one is negative. 28 minus 10 is 10. We're going to divide by 30, and we get 1/3. So d is 1/3. If you want to go with the units, 1/3 what? 1/3 of an inch, okay? Now we want A sub 20, and we are going to use the same formula Now this time n is 20. A sub 1 is 18, okay, plus 19 times d, which is 1/3. And so a sub 20 ends up being 24 and 1/3 because this is 19/3. You can say this is 19/3 or 6 and 1/3. So 6 and 18 is 24. So let's say sub 20. How much material do we need for all 31 ROMs? So we want the total sum. So we use this one or this one. Because a sub 1 and a sub n are both given, that's easier to use. So n 31, a sub 1 18, a sub n 28. And 18 and 28, 46. 46. And 2 cancel each other, 23. 31 times 23, 713. Don't forget the units. As always, if you're dealing with word problems where units are given, you want to give it back with proper units. The factorial symbol and binomial theorem. If n is larger than 0, larger than or equal to 0, and that's an integer, the factorial symbol n factorial is defined as follows. 0 factorial and 1 factorial are 1. N factorial is n times n minus 1 all the way times 3 times 2 times 1 if n is larger than or equal to 2. N factorial can be written as n times n minus 1 factorial. This is combination of n choose R. There are 3 different ways of writing it. This way, parentheses n R, parentheses n R, and it's defined as n. It is defined as n factorial over R factorial times n minus R factorial. This is combination. If we were to simplify this, using that, because 10 is smaller than 12, we're going to keep the 10. But I hope you know 12 means 12 times 11 times 10 times 9 all the way to 1. We're going to go 12 and 11 and we stop at 10 factorial because we see it down here so we can drop those. And we get 132, the product of 12 and 11. The binomial theorem says if you have x plus a to the power of n, combination of n choose 0, x to the power of n, plus combination of n choose 1. So the R value starts with 0 and goes down, goes up. Okay. The n value is the exponent that you have here, x to the power of n. And then this one is now x to the power of n. This goes down the exponent by 1. And then a. Over here, we didn't have it. But if we were to write this, over here would be a to the power of 0, which is 1. Now this is a to the power of 1. And you add them up. Notice the sum of the exponents must be n. And the final one is n choose n a sub n. It so happens, and you can show that this ends up being 1, this ends up being n, and this ends up being 1. Okay, so you can show that. Now, for example, I hope everybody remembers that a plus b squared is a squared plus 2ab plus b squared. A plus b cubed is a cubed plus 3a squared, b plus 3ab squared plus b cubed. Okay, that is the binomial theorem. And also recognize this can be written as a summation, x plus a to the power of n is this summation, r going from 0 to n of n factorial over r factorial times n minus r factorial, x to the power of n minus r, a to the power of r. You can write it in that format. And again, I want you to really work on this and show these two are 1, this is 1, and n(r) is the same as n minus r. If these two add up, that works out to be the same, okay? Just as an example, if I were to show this one, for example, I would say n factorial over 0 factorial times n factorial, which ends up being 1. Again, I'm using this formula. Okay. You can easily prove that. So use the binomial theorem to expand this to the power of 4. So we are going to go with this formula n, or it's easier to start with that. N is the exponent, so 4, and we start with 0, and then 3y to the power of 4. Then 4, 1, okay, 4, 0, 4, 1, 3y to the power of 3, and 2 to the power of 1, and all the way to the end. Now, please understand. So the coefficient is 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. The way we write that, 3y to the power of 4, 2 to the power of 0, we don't write it. 3y cubed, 2 to the power of 1. Let me just write this as 2 to the power of 1. Because you need to know this to add up. So basically, the exponent goes down here, and then we don't have it here. But for 2, the exponent goes up. Now, it is extremely important to keep this in a parenthesis. I've seen sometimes students write this. If you wrote this, this is a wrong statement, because everything must be raised to the power of 4. But over here, only y is being raised to the power of 4. So this is wrong. Don't do that. Now, of course, this we should know it's 1. This we should know it's 1. And 4, 1 is 4. Okay. And believe it or not, this one is also 4 if you go back to the previous one. And you can show that. Because these two add up to 4, they have identical values. If you recall from the previous page, I'm going to, so, and I leave it for you to show that nr and n minus r the same. So in other words, this doesn't change. These two must add up to n, this one and this one, okay? So all you have to evaluate that. So let me erase the mess and continue. Notice this is 1, 3 to the power of 4, 81, y to the power of 4. This is 4. Then 2 times 3 cubed is 27, y cubed. 4, 2 is 6. I'm going to quickly show you that one. 2 squared is 4. This is 9, y squared. 4, 3 is 4. Again, remember that. 2 cubed is 8, 3y. 4, 4 is 1, 1 times 16. Just to show you this one. Okay, according to this formula, this is 4 factorial over r, which is 2 factorial, times n, which is 4, minus r, which is 4 factorial. So you have 4 factorial over 2 factorial times 2 factorial. Now please understand the top is 4 times 3 times 2 times 1. And 2 factorial is just 2 times 1. So 2 times 2 is 4. Okay. And so 2 times 2, cancel out the 4. The answer is 6. Okay. So we are going to multiply out the numbers, and this remains as 81. This is 4 times 2 times 27, 216. Y cubed, 6 times 4 times 9, 216, y squared. 4 times 8 times 3, 96. And then find 96y, and finally 16. And we are done. Here's the last question. It says, find the 7th term in the expression of y plus 3 to the power of 8. One way is, just don't pay attention to that. Expand this all the way to the end. You can do that. And when you're done, count first, second, third, fourth, go with the seventh. This is one way to do it. Another way to do it is to pay attention to this formula, and this one. Okay. Remember, with this formula that I'm going to write, y plus 3 to the power of 8, if I go with this formula, r goes from 0 to 8, y 8 because the exponent is 8. So n factor over r factor over 8 minus r factor over n is 8. Y to the power of 8 minus r, 3 to the power of. If you want to go with that, in the first case, remember, r is 0. We start with r equals 0, right? Second case, r becomes 1. Third case, third term, r becomes 2. Therefore, you should recognize the seventh term, r is 6. So use r equals 6. Okay. And so if I do that, if I replace the r with 6, I get combination of 8 choose 6. This is a combination again. Or 8 factorial, 6 factorial, 8 minus 6 factorial. Y to the power of 8 minus r, which is 6, 3 to the power of r, okay, which is 6. Another way that they look at it, class, according to this, based on the expansion of x plus a to the power of n, the term containing x to the power of j, the first one, okay, to the power of j, has this formula, combination of n over n minus j, a to the power of n minus j, x to the power of j. That's not what they're asking, by the way. It's asking specifically for the seventh term, but you can also use this concept to see what you get. And so with the, remember, with the first term, you have a y to the power of 8, okay? But by the time you get to the seventh term, because this is 8, this is 8, everybody, you have 9 terms. So you add 1, you have 9 terms. And the seventh term has y with the exponent 2, because the 8th one has y with the exponent 1, and the last one has y with the exponent 0, just a constant. Okay, so if you want to go with that route, understand that in that case, j is true. You can go with that one, j is true, and do the math. In any event, so let's replace the seventh term in the following manner. Okay, r is 6. Replace the r with 6. That's all. So this is 8 factorial over 6 factorial times 2 factorial. This is y squared. This is 3 to the power of 6. Okay, because it's 8 minus r. Okay. And so you can write this one as 8 times 7 times 6 factorial. And the reason you do that, so you can drop the 6 factorial, everybody. As you know, 2 factorial is simply 2. And this is 4 times 7 times 729. 20,412 y squared. Again, let me just quickly recap 3 ways to do that. Just don't pay attention to anything like this. Just write the whole thing and see which one is the seventh. The second one, if you want to go this route, notice the first term r is 0. Therefore, when they say seventh term, the choice of r must be 6. If you go with this one, the seventh term, remember this is 8, so it has a total of 9. The ninth one, the exponent on y is 0. The one before that is 1. The one before that must be 2. So this one, j is 2. Either way is fine, everybody.